Okay, first thing I want to talk about today, we are halfway to our first exam in the class. That'll be a week from Friday. So I want to talk a little bit about what you can expect. The first thing you can expect is that a study guide will be released for you this Friday. That study guide will contain just a list of topics that we have covered. We won't be providing a ton of detail in the study guide, but you can use this to think about what have we covered and try for each of those topics, fill it out with as much information as you can, either from slides or from lecture material. You can go back and review the posted lectures on YouTube. That would be my recommendation. Remember that you do have a sheet of paper front and back that you can bring for notes. So as you start to fill out your study guide, you can copy the most relevant, important information to that sheet of notes. My exam design is very, wherever I can, I don't like to have regurgitation type questions. I mentioned this morning in data structures as well, for those of you who are in there. But wherever possible, I will have you be applying the material that we have used. So very infrequently, if you just write down a bunch of facts on your sheet of paper, you're not going to refer to the sheet of paper and it's going to answer the question on the exam. But the reason I give you a sheet of paper is so that it minimizes the amount of memorization that you need. It will be more so use that information and apply it to something that we either have seen before or haven't seen before, but uses the same tool set. So expect minimal multiple choice questions, true, false, expect more, explain your reasoning, show your thought process for something. They're super difficult to grade, but I feel like the exams are more fair that way. And that way I can give generous partial credit for partially correct answers, whereas with multiple choice, you either get it or you don't, even if you have 95% understanding. I don't really like that. So hopefully that helps people to prepare for the exam. I think we'll take a day before the exam to do a full review. So that Thursday, right before the exam, I will have nothing planned in class. I will just come to class and ask, what questions do people have? And I will also spend a little bit of time potentially at the start of each class period next week, just answering whatever questions have come up in the meantime. So if something comes up between now and next Thursday, you're welcome to ask at the start of class. So I'm doing best to make sure that you have the ability to study so that you can do your best on the exam. So study guide coming Friday. I recommend spending some time over the weekend and start of next week, looking at that, filling it out, and making your sheet of notes. Questions regarding the upcoming schedule?
We expect that all the 212 and 300 tests are basically gonna be the same. Not the same like tests, but same days, same everything.
Yeah, I plan to do week 3, week 6, week 9 for both courses. And then this class will also have a final because there's a lot more kind of generic tie it all together kind of material. So it'll be kind of cumulative, but kind of not as well. But just more of a, what do we know about design patterns in general, rather than trying to isolate the individual kinds of questions that would appear on the exams before the final exam.
What's the information cut off for the exam? So stuff we learn on Wednesday will be on the exam.
So the exam is going to be a week from Friday.
Yeah.
So the cutoff is probably going to be most stuff by the end of this week. So anything related to testing, and we're probably covering the strategy pattern between now and then. So I would expect the strategy pattern to be on there. That will be on the study guide as well. Basically, if the topic does not appear on the study guide, I will not ask a question about it. When I design my exams, I go through the study guide that I made and I make questions directly based off of some of the questions or topics that I mention on the study guide. So I highly recommend using the study guide as a way to say, do I know and understand each one of these concepts? And I think that will help for that. And this class does have a lot of kind of information dump types of content to it, and I hate that. I will try not to ask you an information dump kind of thing, but that might be useful to throw on your page of notes so that when I ask you a question that requires the use of the information dumped, you have the information right there in front of you that you can refer to so that you can answer the question that's more than just the regurgitation style question. Like, for instance, we're gonna be covering, after the strategy pattern, we're gonna be covering some code smells, some ways that you can write code that stinks. And there are a lot of different ways, there are lots of different possible code smells. So being able to write down what are all of the associated code smells and your best application of what does that mean, what is it? When I ask you a question that has to deal with some category of code smells, for instance, then you have a list of them on your sheet and you can refer to them rather than having to have memorized this long list of code smells that no one wants to do that. You can mostly just look them up. The question that I have is, do you understand what that means at an intuitive level so that you can write it on the exam? You can show me your understanding of that concept, not just did you memorize and regurgitate the code smell. Other questions? These are great questions so far. Okay, how far did we get? And we were coming back to our exercise redux. So the last thing we covered was we talked about this particular terrible unit test. And then we went through and we asked, what's wrong with it? And it turned out that there were a bunch of things that were wrong with this unit test. So we found that there were a bunch of tests actually being called inside of a loop. The assert equals was done inside of a loop that ran 365 times, actually 364 times. There are 365 days in the year, so I guess we're skipping the last day of the year here. One thing I didn't catch, so it says less than 365, it said less than or equal to 365. Yikes. Does that work on a leap year? No, there are 366 days. So this is a terrible test for many, many other reasons, even that I meant. But the idea is that there are tons of ways this could fail. It doesn't provide us lots of information. We're asserting way too many things. We don't know whether a later assertion would have failed. So the conclusion that we drew was that we wanted to not write logic in our unit tests. We don't want to have conditionals. We don't want to have loops. We don't want to use try catch. We're not going to try to handle any exceptions. We can test for exceptions, but we are not trying to handle exceptions that are thrown. So we're going to go back to our exercise, and here is where we are going to start. So I want us to break into groups of maybe approximately 4. It's totally okay if you're in groups of 3 or 5, approximately 4. And now actually write the unit tests. We talked about this, was it yesterday or the day before? One of those days, memory of a goldfish. We actually talked about the English logic behind what should we be testing here. But now let's actually go write the tests. So go ahead and write down anything from this slide that you need, because what I'm going to do is I'm going to go show the assertion methods slide so that you can take a look at the actual format of the test that you want to write. So go ahead and figure out who your groups are, take any information you need from this slide, and I will go share that slide. And see if you can write 10 or 15 tests over the next, I don't know, 20 minutes. You can break up the work amongst all of you. You can figure out which tests you want to write, which tests you want to write, something of the sort. And let's actually get some experience writing the tests. Does everyone have what they need from this? That's the slide you want. So this is what I am going to leave up while we work.
The grades, like, well, grades and automatic.
Looks like we have a good group of 4 there in the back possibly, and maybe a group of 3 right there. So we're doing the exercise redux, so we're doing the exercise from before, where we're looking at the date class. And then go ahead and you can join either any of the groups that have 3, so the group right in front of you there, and the group in the back. And we are writing actual unit tests now for that. Yeah. The previous one. And share it, make it bigger too if you prefer.
Yeah, I have it actually.
That's you just. It's today. See, there's they then the creator. Well, that is a second parameter for a cert equals, then the first parameter. That being the first parameter, but the second parameter would be date, but with the. No parameters in the constructor. So then you see no parameters in the constructor, without the correctly today. So then we compare that with the our constructed one, which will be the same. You have to do something like
Okay, from the end. So what do you get?
That first one falls out.
So you do days.
It can go.
Yeah.
That makes it easier. So in that situation, we can do this like. It's not a journey, right? So past, I think, I would say. This thing.
Is it number something? Is
So and then I can say, start with the exam, start with this is my expectation. Once I'm gonna call this method to see how many it has. Bridge. Passing, zero.
So it's both switch off.
Just not to make it, just make sure that's the same. Just getting all the expecting it should be.
So you need that.
And which one?
We started off. First of all,
Something.
Oh, it's in your. Oh, dude, I never really. Said my dad.
Okay, see, but it is, when you pass like zero, it's gonna go past.
I'm sorry.
If you're gonna put like today's date in here, and then we pass like zero, in here, it should give us the date. For the Should do.
Yeah, dude, you can stay for a long time.
Should be. So if I pass it, we will pass it zero, if I pass it, I was like, if I pass zero here, it should be my today.
Just basically all together. All of that's.
So when you ask them, like, give me a minute, give me a minute, don't tell them to give me a minute, and ask them, which do you want? Like just today. Last my thing about weird, actually, I was from there asking like, if you go to this guy, right? Go to this guy, give me a day, and it's gonna ask like, who do you want? If I say zero, it's gonna move it today. If I say one, it's gonna give me 0 plus 1, which is gonna be this one. 0 plus 2, all of it. Just the day. But it's like, just the day.
That was the second. Normal.
So we were just.
That's the last.
So actually, this is the only way around.
Was this in the actual stuff that we 24 made? Or did you just pick that up?
I'm gonna call this.
You're creating, so when get they runs, what is it return on day?
So one's a shallow copy, one's a deep copy. Assert equals is gonna look at the deep copy and say, even if these aren't the exact same object, do they have the same values for each of the fields? Whereas assert same is saying, are these exactly the same object? Even if they're exact duplicates of each other, it would return false if they're not the same object.
So we base our dating findings on this, so you say the day, I find out the day. Is it get facts? You say like. Same idea. And I can do very well, some and then.
That's all they do, that they're. We could do a search for the amount of days. So. 31 days or 39 days. You also check.
It's not like that.
All right, so it's 31,
You're not used to
then you also.
You
check
can
for
put in this.
the ones that are 30, ones that are 31.
Almost think that it's like that. So.
Just doing some. Well, yeah, it's because you're saying is.
If you put it this way, they don't have for all the dates.
Most what they put. So. Okay, how this was to fill out. Actually. This one now, since it's really right. Or invalid of this.
This is how.
Oh, so is we.
Yes. What
True, false,
what
or.
today and then into the certain what it is, it is on one, like it's like something that more or less than such. This is for the.
No, not in,
Today.
not in this one, another one you can do is like something where it's like before, about 30 days.
But if it's like for this.
Sorry.
It's gonna be this.
31. Greater than.
Do for January, or for February.
So I would add, like, one that tests the year, that's not you add those, that's the month.
Right, yeah, yeah. But if you're gonna put it like for this week.
There's like.
Actually, go and see you then. Go ahead and read it, like,
We never really tried.
I think the results.
Well, no, wait, we had.
Oh, no, you can only see. So, green or red. All those majorities red. You're expected.
And the actual is what we want.
Kind of want to check in with groups at this point. How do we feel like we're doing? Are we coming up with some good tests? How many tests approximately have we written between groups? 12? It's good. So the next thing that I want to do for maybe the next 5 to 7 minutes, I kind of want to pair up the groups, which is awkward because we have 5 groups. But I want, I will work with this group, and maybe these 2 groups can get together and these 2 groups can get together and show each other the tests that you wrote. And see if you can find any flaws, areas for improvement. So look at the syntax of the test and see if you can improve it in any sense, or how could they be better? Or the test's really good. Also look for any holes in which tests are written. Say something like, what about this? What about, could there be some additional places where testing is needed? I know that likely you haven't written the entire test suite yet. And you probably would have written some more relevant tests. So no judgment here, of course, across the board, but just seeing what did people write, what did people target, are they likely to reveal bugs, and are there any issues with the test construction? So go ahead and do that for a bit. And we will come together and hopefully finish up this last bit of testing slides in about, what, 10 minutes? How's it going?
I just want checking just. Yeah.
Also. Yeah. It's a lot of stuff. Check it out. And I also.
So I would look for something like, we want to use the associated logic to construct something that we can actually compare. So you do something like,
And we're passing on the date to the.
and you can pass in something relevant here to the constructor, and then what is it? What was the first test that you were trying to compare?
Yeah.
It's exactly the same object. So what would be a reasonable way to do this? You would say, I don't think there's anything that we would really need to assert save. It's all good. Something like this quite yet. That occurs if you expect that something like I've done a shallow copy, and I want to make sure, I want to verify that it was a shallow copy.
That's what it's like.
Yeah, so you could do that right away. Make a new date, set it to 1,1,1, and do something like assert not null.
Just like a certain one will not work.
Yes. And that way, if it fails, then we get the associated message, just created date is null, which we don't want if we pass in the date constructor that sets this. You could also do this with just today's date, where it takes no parameters, and now here, this would test your constructor to make sure that it does actually get today's date and not just set it to null. That would be useful as well. So then we just have to name the test, so we would have an at test. Something like whatever the default timeout happens to be. And then you would have the name of the test. So this would be something like, so what we want to name this.
It may be here.
So this is not something.
Here as well as the message. Before.
Like create date not null one. And now if this fails, we can see the name of the test. You can see the error message, and this would tell us exactly the issue. What we haven't specified here is something like, which constructor did we call? Did we call the default constructor for today's date or not? So we probably want to put that in here somewhere. But that would be a good unit test is to verify this. Do we feel like this test is likely to fail? Not really. So the best tests that you're going to want to identify are going to be those that are likely to fail. So if we were to structure something by how likely is it to fail, what do you think would bubble to the top? We would add all of those methods. What is not likely to fail? What is likely to fail? Yeah, if you like wrapping the day or something like this, what would that test look like?
So the time that.
Search.
We probably want to assert equals. We're going to create the expected date, and then we would have the date after we added 31 days or something like perhaps the month. So we would write add test with the associated timing. And I'm just going to skip into the actual project. We can name whatever we want. We're going to make an associated date to be, I don't know, today's date. Now we want to add 31 days to that. So we want to say d dot add days. 31 days. The issue is, does it become easily testable if we use today's dates? Because if we test this again tomorrow, how do we verify that tomorrow's date was 31 words? If we make some expected answer here that doesn't use the code, that's gonna be wrong tomorrow. So maybe we don't want to use today's date. We actually want to hard code this to be a particular date. We'll set this to be. Yeah, why not? I love it.
So,
I can buy, because it's year, month, day. Yeah, year, month, day, so we're gonna have, we'll say it's this Christmas, 2024, 12, 25. And then D dot add days 31. What is 31 days after Christmas? How many days does December have? 31. 31. We would expect after 31 elapsed days that it would be. Is it the 24th or the 25th?
Or the 2025 about six.
So now we say. Expected. Equals. One day moves it ahead. 7 days is the same day the next week. So 31 days should be the same day next month. When I think about it. So we should have 2025, 125.
I did the job, but I still got it.
You should have to check, like, it's not what one, you're checking too, because like, they're all different, like, you could have 30 days.
Right, but if we set it to be December 25th, then it's going to be that case for this exact example, but you may want to come up with a couple other tests that test things like. On a leap year, do we correctly associate that with the associated rollover, et cetera? So now we just want to say, we want to assert equals. We need some message in there. What does the message say? What should we see if this fails? 31 days after Christmas is not. Yeah. It's not the correct date. Something like that that tells you exactly what you did. So.
Wait, I'm confused, why do you say that? No, I get the message part, but why the 31 days is not. Just lost her.
Because it's specific.
What is 7, what day of the week is 7 days after today?
Same day.
Same thing. So 31 days after the same day of the month should be,
Same like Thursday or Wednesday.
it should be the same date.
Because you're doing that for separate 30 days. So that.
Yeah, so we have 25, 26, 27, 28, 29, 30, 31, 1. After 7 days, we know this because New Year's always falls on the same month. And if we do 25 plus the, because that's the first, there are 24 days between the first and the 25th. 24 plus the 7 gets you to be 31. So now we just want to say, what comes first, the expected, the actual.
So that
Expected. And we should probably, instead of calling this D, we should call it actual. And now we can actually use almost those exact same words to show that means. And now you can see that this is what we were testing to make sure that when we add days to actual, we get expected. Tests like this. How's everybody else doing? Were we able to check each other's tests well?
So this one will just get away from each one because then make sure that we add days to add month.
Yeah.
So it's going to do that date. First, so that's.
All right, let's go ahead and wrap this up, and I'd like to try to cover just the last few slides in this slide deck by the end of the period. Does anyone have any questions or concerns about this activity? Hopefully this helps you to be able to think about and write some unit tests. So as I hinted at before, we're going to be starting to implement some unit tests in some of the labs that we're going to be doing starting next week. So you will get a chance to do some extra practice and get some extra practice with this as we move forward in the class. Okay. Your tests can have helper methods. Helper methods are very useful because there can be redundancy between the tests. If you find yourself needing the same logic between multiple different tests, that's not ideal. It would be great if we could factor that out. So you can make private helper methods that do the same associated logic. So now we take the add helper tells us now we'll take a date, a year, month, and day, the number of days to add, and the associated expected year, month, and day. And then that add helper does the assertion for you. And now you can call add days within same month 1, and that calls the add helper. Add days wrapped to next month 2 now uses the exact same add helper. So you just have to now pass in the date, days of change, and the expected date, and it will do the assertion for you. Lots of redundancy factored out, lots of pain removed from this process. If you use multiple helpers, the actual tests that you write can be very short. You will know to use these helpers if you actually design your tests before you start writing them. So I would, in the future, think about what kinds of tests should I write? That associated thought process would be something like, how is this most likely to fail? Start listing the ways that it's most likely to fail, and then think about what is shared in common between multiple of these. Can I factor that out into its own method? And that way, multiple of these tests can all call the same method. It also makes it way easier to read. One other thing you can do is if your helpers work slightly differently, then you can overload them. So here's an add helper that breaks down the year, month, and day, and another one that just passes in the date. And that way you can call the associated helper that makes the most sense given your own test construction. So now we have 2 different add helper methods. So we've hopefully seen this before with regards to method overloading, but this is one case where method overloading can be very useful. Questions on writing helper methods or overloading helper methods? Next thing I want to talk about is regression testing. So in computer science, we have constant changes to ongoing applications. You can imagine that you make some changes to one of your projects, and then something that used to work no longer works. So when code changes over time, grows over time, you will find that this happens frequently. If you go fix a bug, a new bug, it can reintroduce an old bug. So regression testing is the concept of going back and executing prior unit tests after you change your code. So anytime you make changes to your code, you can run your entire test suite and make sure that the functionality that used to work still works. Rather than doing this yourself, usually you will write a script or utilize a service that runs your test suite for you whenever you make an associated code change. So you don't usually have to think about this, but you will want to be familiar with tools that implement this functionality for you. One of them is GitHub Actions. If you've used GitHub before or know about it, you can program certain actions or scripts to run on certain GitHub commands. So if you do something like you want to commit your code to your current GitHub repository, you can set it up to say, here's the associated test suite. Whenever I call commit, run my test suite. Only if all of these tests pass, do you want to accept the commit, accept the code changes. If the code change causes at least one test to fail, report that result, but don't actually add the code changes from the commit into your repository. That allows you to fix the bug before you introduce it to the entire project. So you can do this to make sure that old bugs are still fixed. It also gives you a minimum level of working functionality, meaning that whatever tests you have written, you know that all of those tests always pass. Just talked about this. We call this in general continuous integration, and you'll actually be implementing this in software engineering, assuming you take it from me. I have no idea what the other professors who teach it do. But if you take software engineering from me, you will be implementing continuous integration in GitHub for a project that you make. For now, just know about it, know that it exists. We talked a little bit about writing tests before even starting to code. So when should you be writing your test suite? Do we have all the information to write tests before we begin coding? The answer is yes, we do. What do we think the benefits and drawbacks are of writing the tests before we write the code?
Probably helps you give you a good idea of what you want to write and then like what to expect. Like,
Yeah, you do a lot of the planning process as you are writing the tests. You will find that stuff that you would have missed or failed to think about when you wrote the code, you think about while you're writing the tests, and then it's in your mind when you go write the code. If you write code after writing tests, your code will have fewer bugs. You can also run your tests at any time during development. If you do this, you will find that tests that you expect to fail will fail, but you will start to see that some of the tests that you've written should start passing as you implement the associated functionality. If tests that you expect to pass don't pass as you are writing it, you don't have to have an entirely full program written before you know there's a bug in part of it. The drawbacks to writing tests before code is that it's time consuming. If you really know what you're doing and could have written that code from scratch without making any bugs, it will take longer to write the tests. It's generally just a good idea. So we call this test-driven development. I didn't manage time quite well enough, and we have a couple more slides to go. We will cover those tomorrow and start talking about our first design pattern. See you tomorrow for that.